Hello students, welcome to the second part of the lesson, Materials, Metals and Non-Metals. We have learned to differentiate metals from non-metals in the first part of this lesson. We did this by studying physical properties such as malleability, ductility, sonority, heat and electrical conductance of metals and non-metals. Finally, we could appreciate the applications of metals in our daily life. Now, let us learn some of the chemical properties of the metals and non-metals. We see reddish brown flaky coating over iron parts of gates, windows, bicycles, motorbikes, cars, etc. We call this deposit as rust. Rusting is a process in which iron metal reacts with moist air present in the atmosphere, that is, with water and oxygen to form hydrated iron oxide. Have you seen copper rusting? At home, you might have observed copper items such as copper wire or copper vessels when exposed to moist air for a long time acquires a dull green layer on its surface. The green material is a mixture of copper hydroxide and copper carbonate. That is, copper reacts with oxygen and carbon dioxide in the presence of moisture. Copper carbonate is a blue-green compound. Rusting is commonly called as oxidation and takes place when metals like iron and copper are exposed to moist air for extended period, leading to what is known as corrosion. For rusting, metals need both oxygen and water. Can copper combine with oxygen in the absence of water? Yes. Copper reacts with oxygen in the absence of moisture to give copper oxide. To carry out this reaction, take a few copper turnings or wire and heat it on a spirit lamp or a Bunsen burner. Copper combines with oxygen to form black copper oxide. Do other metals also react with oxygen? Yes. In class 7, you have learned that magnesium burns brightly in air and produces ashes of magnesium oxide. Note, this reaction occurs in the absence of moisture. So students, we now know that the metals react with oxygen to produce metal oxides. Now, you may be curious to know whether non-metals also react with oxygen. Indeed, they do react. For example, sulfur burns in air on gentle heating with a pale blue flame and produces sulfur dioxide gas. Red phosphorus, when heated, reacts with oxygen present in the air to form phosphorus oxide. So children, we can generalize that both metals and non-metals do react with oxygen to form their respective oxides. That is, metal plus oxygen gives metal oxide and non-metal plus oxygen gives non-metal oxide. Let us now learn acid-base nature of these oxides.
Students, now we are going to see something which is familiar in our day-to-day life. I have some very old nails from my cupboard. Can you see what has happened to these nails?
It's rusted.
It is rusted. Okay. And now we are going to investigate what will be the nature of this iron oxides. It will be basic or acidic. It is what is the investigation is. Okay. So let us perform an experiment and learn what is the nature of these oxides and hydroxides.
Iron oxide or rust is least soluble in water and remain as suspension. This suspension is a mixture of hydrated iron 3 oxide, iron 3 oxide hydroxide and ferric hydroxide. Upon testing, the suspension changes red litmus paper into blue. This shows iron oxide is basic in nature. Aqueous solution of magnesium oxide turns red litmus paper into blue and leaves the blue litmus unchanged. This is due to the formation of base magnesium hydroxide from the reaction between magnesium oxide and water. Then, can we conclude metal oxides are basic in nature? If so, what will be the nature of non-metal oxides?
Now students, as we have burned magnesium ribbon, now we are going to burn sulfur. Okay? And sulfur is a metal or non-metal?
Non-metal.
Non-metal. And we are going to test what will be the nature of the oxide of non-metals. Okay? Are you all ready to see this?
Yes, sir.
Students, this spoon is called as deflagrating spoon. Okay? And we are going to take sulfur in this spoon. Can you on the gas? Can you observe the color of the flame? What is the color of the flame which you observe? Okay. Now the sulfur has burned. Now we are going to add water and check for its nature of oxide. Okay. Now let us test for blue litmus and red litmus. Okay. What has happened to blue litmus?
It has turned to red.
What has happened to the red litmus?
It remains same.
It remains the same. So what you can conclude from this?
It's acidic in nature.
Yes, the nature of sulfur oxide form is
Acidic
in nature. Okay. So, and sulfur being a non-metal, the non-metal oxides generally are acidic in nature.
We already learnt when sulfur is burnt in air, it combines with the oxygen in air to produce a gaseous product, sulfur dioxide. A solution of sulfur dioxide in water turns blue litmus into red and leaves red litmus unchanged. This clearly shows the acidic nature of sulfur dioxide. Sulfurous acid formed is responsible for the observed color change. Similarly, phosphorus oxide when dissolved in water forms phosphoric acid. Phosphoric acid turns blue litmus paper red and red litmus paper remain unchanged.
The non-metal oxides generally are acidic in nature. So this is the conclusion which we get from this experiment. And metal oxides which you already seen. What is the nature of metal oxides? Basic in nature. Have you all understood clearly?
Yes, sir.
Okay.
This observation confirms that both sulfur dioxide and phosphorus oxide are acidic in nature. That is, in general, non-metal oxides are acidic in nature. Now I am confident that with this knowledge you can identify metal and non-metal from the list of commonly used laboratory acids and bases. Look at the table. As we learned, bases are formed from the corresponding metals and acids are the products from the respective non-metals. Let us read out the names of bases mentioned in the table and identify metal part in it. Calcium hydroxide. Calcium is the metal. Magnesium hydroxide. Magnesium is the metal. Potassium hydroxide. Potassium is the metal. Sodium hydroxide. Which is the metal in this? Yes, sodium is the metal. Zinc hydroxide? Yes, of course, zinc is the metal part constitute this base. Now, let us focus into the acid column and identify non-metal part embedded in these acids. Sulfur is a non-metal in sulfuric acid. Chlorine is a non-metal in hydrochloric acid. Nitrogen is the non-metal in nitric acid. Carbon is the non-metal in carbonic acid. And finally, sulfur is the non-metal present in sulfurous acid. Let us see how metals and non-metals react with water. Different metals react differently with water. Metals like aluminium, iron and zinc do not react either with cold or hot water. But They react with steam to form the metal oxide with the liberation of hydrogen. Whereas lead, copper, silver and gold exhibit no reaction with water. Are you aware, students? Potassium and sodium are stored in kerosene, or else it will be coated with paraffin wax. To get the answer, let us perform an experiment.
Students, we have seen metals, and metals are usually hard in nature. But now here we have one such metal which is very soft in nature, which can be cut into pieces. So here is an exception. The metal name is sodium. Okay. Now the sodium is very reactive. To handle sodium, it is very hard. So it will react with the moisture and water which is nearby to its environment. So only it is stored in liquid paraffin or kerosene to prevent its reaction with the moisture or the water molecules which is present near by its surroundings. So now let us take a piece of sodium metal, dry it in the filter paper, and now let us put it into water and see its reactivity. See, it is very reactive. Are you able to observe that? Now, let us test the nature of hydroxide formed by the sodium metal. Okay. Now we are taking red litmus paper and blue litmus paper, and we are going to test. Now are you able to see the color change? The red litmus has turned into blue and blue litmus remains
Same.
Now what can you observe from this?
Sodium is basic in nature.
Sodium or the sodium hydroxide?
Sodium hydroxide.
Sodium hydroxide which we tested is basic in nature. Okay. So this is the conclusion which we get from this experiment, and metal here used is sodium which is very reactive, and you should handle it with safe. Okay. Okay.
What happens when sodium reacts with water? As we already seen, sodium reacts rapidly with water to form a colorless solution of sodium hydroxide and hydrogen gas. Therefore, red litmus paper turns blue when tested. In addition, it immediately catches fire, producing a lot of heat. We call this type of reaction as exothermic reaction. Can you answer now why sodium is kept in kerosene or coated with paraffin wax? Yes, sodium and potassium are highly reactive metals, and they react vigorously with water and is even explosive. In order to prevent contact with the moisture, these very reactive metals are stored in kerosene or coated with paraffin wax. Generally, non-metals do not react with water. This is the reason for storing white phosphorus in water. As we know, white phosphorus is a very reactive non-metal and catches fire if exposed to air. To prevent the contact of phosphorus with oxygen, it is stored in water. Students, so far we have learned about the reactions of metals and non-metals with oxygen and water. Let us recall them once again. Metals react with oxygen to form metal oxides which are basic in nature. Non-metals react with oxygen to form non-metal oxides and are acidic in nature. Sodium and potassium are highly reactive metals and react vigorously with water and produce a lot of heat, and frequently it catches fire. Hence, sodium and potassium stored in kerosene. Some metals like iron, magnesium react slowly with water, but metals like copper, silver, gold do not react with water. Generally, non-metal do not react with water. Therefore, very reactive non-metal like white phosphorus is stored in water. Here are some questions to ponder about. Often, you must have seen white coating on the inner surface of copper utensils. What it is and why is this recommended? Earlier, copper vessels were used to cook food. This is because thermal conductivity of copper is highest, which helps to cook food fast. But it is not safe to cook food in copper vessels. This is because copper tends to react with salt and soaring agents in food and may cause food poisoning. Therefore, a coating on the inner side of the copper vessel is a must, and it is done by coating it with a thin layer of tin, and the process is commonly called as kalai. The kalai coating fades with use and need to be retinned after 6 to 8 months of usage. Kalai is also scientifically called as enameling or tinning. With the advancement of technology, we have discovered safer materials to replace copper cookware. Most often, stainless steel cookware with copper bottom is used. Why is there no rust on the rail track even after being in the open throughout the year? It is not that railway tracks will not rust, but it takes lot of time to rust. This is because the iron or steel which is used in making railway track is composed of heavy and high quality steel alloy, which is less susceptible to corrosion when compared with the steel used for buildings. These tracks also have a thicker cross section. When the rust forms on the surface of the track, it acts as a barrier which then slows the rate of further corrosion. The top and upper surface of the rail track does not usually corrode because friction and wear keeps it polished and free of rust. The gaseous oxides found in the atmosphere, including carbon dioxide and nitrous oxide, are non-metal oxides. What happened to the red and blue litmus paper when tested with rainwater? As we know, non-metal oxides are acidic in nature, so blue litmus paper turns to red. When the air reaches high concentration of such non-metallic oxides due to air pollution, the rainwater dissolves these oxides, and this constitutes what we call as acid rain. Acid rain is the leading cause of degradation of white stones of Taj Mahal and other monuments. Find out the locations of the deposits of iron, aluminium and zinc in India. Mark these in an outline map of India. In which form deposits found? Iron is found in Jharkhand, Orissa and in Madhya Pradesh. It is found in the form of iron oxide. Aluminium is found in Orissa, Jharkhand and in Gujarat. It is found in the form of bauxite. Zinc is found in Rajasthan and Andhra Pradesh. It is found in the minerals like wurtzite and sphalerite. Take a piece of burning charcoal and collect the gas evolved in a test tube. How will you find the nature of the gas? Write equation for the reaction taking place in the process. We can collect the gas of burning charcoal in a test tube. When charcoal reacts with oxygen, it forms carbon dioxide gas. To the gas which collected in the test tube, we need to add some water and shake it very well and test the solution with both red and blue litmus paper. Blue litmus paper turns to red and red litmus paper remain unchanged, which implies that the gas is acidic in nature. Carbon dioxide dissolves in water to form carbonic acid, which is acidic in nature and turns blue litmus red. Students, I hope you enjoyed and understood the chemical reactions of metals and non-metals with oxygen and water. We will come to you with still more exciting chemical reactions of metals and non-metals in the next part of this lesson. Thank you.